We often talk about new and ongoing experiments on board the station, but today we're going to talk about one that's complete and now providing some interesting results. Lori Meggs at the Payload Operations Integration Center at the Marshall Space Flight Center in Huntsville, Alabama, is going to tell us more about the Integrated Cardiovascular experiment.
The Integrated Cardiovascular experiment was recently named one of the most compelling studies from the ISS. Today we learn more about this study and how the results are already helping folks here on Earth.
So the Integrated Cardiovascular study was one done to look at the long-term effects of spaceflight on heart size, heart function, and how those interplay with the risk for cardiac arrhythmias.
Why was it important to study this in space?
Yeah, it was important because we know from ground-based analogs for spaceflight, bed rest studies, and some flight studies that the heart tends to get smaller with less activity. In the past, the countermeasures in space weren't as good, and the astronauts' hearts would shrink. The muscle would get smaller. The heart is muscle, and like any other muscle, the more you work it, the bigger it gets, and the less you work it, the more it atrophies. So the astronauts' hearts would get smaller, the volume in the hearts would get smaller, and there was one report of a cardiac arrhythmia on an astronaut who was on the Mir space station about 2 months into his stay. So the concern was that these changes in heart function and size could lead to possible arrhythmias. And besides just the arrhythmias, lead to problems when you land from space. Spending 6 months in space, going from Earth to Mars, landing, having to function, especially in an emergency situation, is very important. The study had 13 astronauts, 4 of them women. They came from Expedition 20 all the way through Expedition 34. There was a lot of pre-work for this, bed rest studies where we had patients spend 5 weeks in bed, do supine cycling, rowing ergometry, all these things versus controls, looking at exercise and the changes with heart function and muscle thickness.
So I know you have results now, but I'm kind of curious, you had 4 women, the rest men. Was there any difference there?
So far we haven't really seen a difference between the men and women, but it's not a large number of either, and so it's hard to say that we've had enough to find that difference, but I think important that in what we've seen, it looks about the same. Interestingly, heart function before and after 4 to 6 months of spaceflight really stays the same. There's no change in how well the heart squeezes, how much blood it pumps, how thick the muscle gets, and I think that really speaks to how well the countermeasure is on the space station right now. And they have 2 hours of exercise time built into the system. I'm not sure that it's always done, but what they do seems to be very effective.
What do you hope comes from this experiment? What should come out of that, and why should people on Earth care about it?
The 2 things that I'm most concerned into this study is long-duration spaceflight, and if we go through with interplanetary travel, near-Earth objects, then to make sure that the heart isn't compromised in such a way over 6 months in space that the astronaut can't function when they land. I think that's very important. Besides that, there are some results that are relevant to Earth right now. For example, one of them is athletes. The way the athlete heart changes with exercise training and when they stop training is very relevant to the information we get from the space station, and vice versa. We're learning constantly more things about it that we can apply to athletes who come in with heart problems. In the same way, there's a population of patients who have something called POTS disease, postural orthostatic tachycardia syndrome, and these are mostly women. They're young, usually, and they have difficulty standing upright for very long periods of time. Historically, they've exercised a lot, and then something happens and they stop. They get pregnant, they get injured, and when they stop exercising, their hearts shrink, just like we worry about in the astronauts. Well, using the exercise program we developed in bed rest and have been using to help the astronauts on the space station, we made an exercise program for these POTS patients, and it has been a great cure for many of the patients. And very pleased with the outcome of that. The exercise is able to make their hearts larger, make them stronger, and now they're able to lead more normal, realistic lives.
So how does the common everyday person learn about these countermeasures, learn about the exercise programs?
I think part of the outreach of this is for specifically the POTS program. There are a few national centers that really focus on POTS patients. But besides that, I think an important idea is that exercise is beneficial for anybody who's aging. Healthy aging population needs to be exercising. We know that The amount of fitness somebody has in midlife really relates to long-term mortality, and the kind of exercise the astronauts are doing on the space station keeps their hearts strong and flexible and young. And if everybody can start to move that way, then people will be more functional as they age, happier as they age, feel better.
So I better get out of here as quick as I can and go for a run. You're taking a live look now at the Payload Operations Integration Center, busy at work this morning, helping with some of those robonaut activities and anything else that the crew may need science-wise.